next example that we'll look at is the example of a proton transfer. Sometimes it's hard to distinguish nucleophile attacking electrophile from proton transfers, and in many ways they're similar, except in this case it's going to be something that has an electron density, lone pair of electrons, and essentially all that's happening is that original material is picking up a proton. So we can see that the ketone carbonyl is picking up a proton from the hydronium ion in our first example. And in our second example, water is picking up a proton from the protonated ketone. Let's see if you can do an example. Please stop the video and see if you can predict the products. Okay, so I would classify this as a proton transfer. The hydroxide is picking up a proton. I draw out the original structure in the sense I've got 3 carbons. There's a bond to the oxygen. There will not be a double bond because the pi bond was broken and the electrons went to the oxygen. The proton was picked up, so one of the products that we will have here is H2O. And this arrow right here is saying that the pair of electrons that are used to make a bond between the carbon and the hydrogen will now be involved in making a pi bond between this carbon and this carbon. And so I'll draw in the corresponding pi bond. Note the conservation of charge in that my original reactants have a negative charge and my products also have a negative charge. As a last example, we have the rearrangements. The rearrangements will involve carbocation, and as a result of the rearrangement, we'll move from a somewhat unstable carbocation to something that's more stable. So for example, you'll notice here that we have a secondary carbocation, and in the end we have a tertiary carbocation. So the rearrangement occurs because there's an enhancement in stabilization. What's happening in the first example is that we have what we can call an alkyl transfer. Sometimes it'll be as simple as a methyl transfer. Sometimes it'll involve a longer chain. Note that the tip of the arrow is starting at the pair of electrons. In a sense, the whole pair of electrons plus the CH3 group is moving over to where the carbocation is. As a result, it'll leave a positive charge right here. In our second example, notice that we're going from a primary carbocation to a secondary carbocation. That's an improvement in the stabilization of our carbocation. What's moving in this case? Well, it's not so much that the positive charge is moving, but rather we have what we would refer to as a hydride shift. So you would need to write in the bond between carbon and hydrogen to highlight what's happening. And so I'm going to start the tip of my arrow and point the arrowhead to the positive charged carbocation. This is the hydride shift from this carbon to this carbon. As a result, we have a new bond being made to the terminal carbon. And of course, there are 2 other hydrogens there. We do not need to write them in. And in fact, I don't need to write in the hydrogen that I just wrote in, but I'm writing it in now so you can see what happened. So those are examples of rearrangements. To finish this video, let's look at a couple of examples. There are further examples also in the chem activity that I encourage you to attempt, and you can check your answers in Moodle. Many times what happens is in an organic chemistry mechanism, there isn't just one of the basic moves, but there's a couple of the basic moves. It's helpful for you, at least at first, to mentally recognize them so that you can see that these 4 basic moves essentially comprise all of the organic chemistry mechanisms. So let's look at this first example, and I'm just going to do a little bit of labeling to highlight which basic move is happening. So for instance, in this first step, we have leaving group leaving, forms the carbocation, and then we have the nucleophile attacking. That's all that's going on here. In our second example, the two basic moves that we've just mentioned, in a sense, are happening in one concerted step. So I could say, oh, well, the nucleophile is attacking and the leaving group is leaving. Now, you may recognize these reactions as those that we studied in first year. So this first example A is an example of an SN1 reaction. This second is an example of an SN2. We will revisit these reactions in the second semester of the organic chemistry course. So I'd like you to be able to look at examples where the curved arrows are given and for you to be able to predict what the products are. But I would also like you to be able to look at examples like this, where I show you the product, but I don't include the curved arrows. I'd like you to be able to recognize how things have gotten changed and for you to be able to include the curved arrows. Let's go through this example. So it's helpful to see how things got altered. So I'm starting from my ester molecule here, and I look down at the next intermediate, and I see that the oxygen at the top has gained a proton. Ah, this is a proton transfer. Now you might be wondering what the heck this BH plus is, and this is meant to just represent any kind of generic acid that can donate a proton. If I now compare my first intermediate to the second intermediate, I can see that the second intermediate has an extra bond to an OH2 group. Ah, this means that water as a nucleophile has attacked. So this is simply nucleophile attacking an electrophile. If I compare this intermediate right here to the next intermediate, I can see that all that's happened is there's been a proton transfer. So that's what I will show with the curved arrows. The next step also involves a proton transfer. I just pay attention to the fact that this oxygen right here has picked up a proton. What happens next is leaving group leaving. It happens in this fashion. A pair of electrons come down here to form a new pi bond, and the carbon loses this alcohol group. This is just leaving group leaving. And then finally, we have a proton transfer. So 3 of the basic moves were included in this overall reaction mechanism. The only thing that was missing was the rearrangement. Now at first this may seem somewhat complex, but again in second semester you will be able to write out this entire mechanism without any scaffolding as I've provided here. I hope you have found this short video to be helpful in seeing what's involved in the curved arrow notation and also introducing the 4 basic moves that you should be very familiar with.